Hello viewers, welcome to my channel, Ostino Educational Center. Today we'll be looking at the subject chemistry, and more importantly we are going to be dealing with the branch of chemistry known as the organic chemistry. Organic chemistry. As we all know, there are different branches of chemistry. We have the analytical chemistry, we have the physical chemistry, we have the industrial chemistry, we have the organic chemistry, we have what we describe as the general chemistry. But today, we'll be looking at organic chemistry. As a way of introduction, I will be dealing with the definition of what we know as organic chemistry. So we can therefore define organic chemistry as the branch So, like I said, that organic chemistry is the branch of chemistry that deals with organic compounds. So, in this definition, we'll be dealing with the word organic compounds and its derivative, meaning that there are other compounds that organic compound is being derived from. And so, based on that, we will now try to find out what is the word organic compounds that led to organic chemistry. And so, we'll be dealing with the word organic compounds. So, by also the way of definition, organic compounds are organic compounds. They are compounds of carbon and its derivatives. And so it simply means that the major constituents of organic compounds are carbon. And so therefore, organic compounds can also be defined as compound of carbon and hydrogen. Majorly, compounds of carbon and hydrogen. So we can use the word C and H, but we can also see other compounds like nitrogen, oxygen, sulfur, and even sometimes metals attaching to organic compounds. As long as the compound is majorly carbon and hydrogen, they are described and known as organic compounds. The ability of carbon to interact with itself, carbon interacting with itself, meaning carbon bonded to carbon, carbon bonded to carbon, carbon bonded to carbon to form a long chain hydrocarbon is described as the word catenation. And so the origin of organic compound came as a result of carbon interacting with each other, and that gave rise to this series of organic compounds. And so organic compound becomes the compound or the chemistry of carbon and hydrogen basically. And so from here, you will see where carbon is interacting with carbon. Carbon interacting with carbon. Carbon interacting with carbon. It can keep interacting until it forms ring, it forms long chain, it forms branch chain, as long as it is interacting with each other. The process whereby carbon interacts with each other to form a long chain hydrocarbon is known as catenation. And so for organic compound to come to existence, catenation must exist. And so we will now look at what are the basic composition of organic compounds. What is organic compound made up of? So quickly, after our definition, we will be going into the composition. Since we have known that organic chemistry is the chemistry of carbon and its derivatives, and then we have also defined organic compounds to be the compounds of carbon and its derivatives, which can also be described as the chemistry of carbon and hydrogen, basically. And I said that the ability of carbon to join to each other to form a chain, a long chain, is described as catenation. Take note. So organic compound cannot come into existence without the process catenation. And that catenation is as a result of carbon interacting with carbon. So we'll be looking at composition. What are the basic composition? What are the basic composition of? One, organic compound is made up of basically carbon and hydrogen, basic element. So they are made up of carbon and hydrogen, basically. Apart from carbon and hydrogen, organic compound is also made up of oxygen. Sometimes you will see oxygen as part of the composition of organic compounds. You will see nitrogen as part of that. You will see phosphorus as part of that. You will see sulfur as part of that. And then sometimes you will see metals. Metals. For example, metals like magnesium. You will see metals like lithium. These are the basic composition of organic compounds. And so, with that, since organic compounds are made up of basically carbon and hydrogen, there are elemental analysis, because there are elements that are carried out to detect their percentage composition. Because since they are made up of, we want to know how much of carbon, how much of hydrogen, how much of oxygen may be present in a certain organic compound. That will lead us to what we describe as empirical and molecular formula. And so, dealing on empirical, and the molecular formula has a relationship. An empirical formula shows the simplest whole number ratio of each atom present. The simplest. Some texts will say the smallest whole number ratio. And so, looking at the empirical formula, empirical formula. By definition, empirical formula shows the by definition, the empirical formula shows the simplest whole number ratio. So the word you must underline is the simplest and the ratio. So it shows the simplest whole number ratio of each atom. So we can actually use the empirical formula to predict the composition of each element, their percentage composition of each element present in an unknown compound. If we have a certain organic compound, we can use the empirical means to determine or detect the percentage of each element present, because these elements they come together to form the compound. And because these elements are coming together to form compound from our basic chemistry, they have their ratio at which they interact to make up the bond. And so because this ratio must be determined in order to predict which amount of carbon, which amount of hydrogen, and which amount of oxygen is making up these compounds. So the empirical means becomes necessary. And so the empirical formula shows the simplest whole number ratio of each element present in the compound. While the molecular formula shows and so you can see the basic difference there. This has to do with the actual, this has to do with simplest. And so we can mathematically, by a way of calculation, to say that the molecular formula with this molecular formula N.F, the molecular formula can be equal to empirical formula multiplied by N, where N is the number of the atom, where N is the number of atoms. So we can also say that the empirical formula, also by way of relationship, to say that the molecular formula N.F divided by N will give us the empirical formula. So we can relate this to empirical and molecular formula. And then for chemists, those of you that have been finding it difficult to understand organic chemistry, you must first of all understand what we mean by organic chemistry. From there, you understand the origin of the chemistry, which is organic compounds. The word organic chemistry simply means organic compounds. This chemistry of organic compounds. And then, if you understand what are organic compounds, and we say organic compounds are compounds of carbon and its derivatives, meaning that compounds that deals with carbon majorly are organic compounds. We'll step a little further to tell you that organic compounds does not only comprises of carbon, but there are other elements such as hydrogen, oxygen, sulfur, phosphorus, nitrogen, metals such as potassium, sodium, lithium, magnesium, and so on. These also pair, they also interact with carbon to make up organic compounds. And I said that organic compound couldn't have been possible without the ability of carbon to interact with itself. So it was very important to understand that carbon has the ability to interact with itself to form long chain hydrocarbon. Listen, carbon has the ability to interact. It is not all elements that has the ability to form long chain hydrocarbon. The next element that has such ability to do same as carbon is silicon, which is the second member of group 4 after carbon. And so silicon form there, but silicon form what we describe as xylene and unstable compounds. But carbon form a more stable compound with itself called the alkanes. And so that ability of carbon to interact with itself, an element to element, a same element interacting with it, with same element interacting with the same kind of element to form a long chain hydrocarbon, is what we describe, remember, as the word catenation. So organic compounds couldn't have been possible without this process of catenation. So catenation is like the bedrock of organic compounds. So compound like organic wouldn't have been existing without this. And that is why carbon becomes the unique compound in the unique element in organic compounds. Without carbon, that compound ceases to be called organic compounds. And carbon can only do that with catenation. And then, quickly, as a way of summary, we looked at the composition of organic compounds. And then, like I said, that led us to what we call the empirical analysis and molecular. So with the empirical analysis led us to what we describe as empirical formula and then molecular formula. And then we said that molecular formula and empirical formula has a relationship, and of course the similarities also, they also have differences. And so empirical formula simply deals with the simplest whole number ratio. The simplest whole number, meaning the smallest. The simplest whole number ratio of each atom. Some texts say each element present. So meaning that each of the elements empirically in the smaller form can be calculated, can be determined. And then molecular formula deals with the actual in totality, everything put together. Molecular formula deals with the exact, the actual whole number ratio, what it should be. That is what molecular formula deals with. And then we also say that mathematically they can also be related as this, that n dot f is equal to e dot f times n, as n is the number, is a whole number. We have e dot f will be equal to n dot f divided by the n, which is the whole number. You can see all of them having a whole number. And so, in our next video, we'll be looking at the mathematical expression that has to do with analytical and empirical determination. Solving some problems using empirical and molecular formula to see how we can actually determine their percentage composition in an unknown compound. So sit tight, don't go anywhere, click the subscription button, like and share as I see you in our next video. Thank you and God bless you.
Good evening, my viewers. Today we will be talking about the empirical and molecular formula determination. In an empirical formula and molecular formula determination, in our previous video, we cited out that empirical formula shows the simplest whole number ratio, while molecular formula shows the actual number. In the video that we have been dropping, we express empirical formula as a ratio of the smallest atom present in a particular organic compound. And the molecular formula shows the actual number of each atom present. Like we likely said, that today we'll be dealing with the mathematical expression of determining the different empirical formula and molecular formula of an unknown organic compound. By a way of mathematical calculation, we will say that empirical formula E dot F will be equal to molecular formula divide by the number of atoms present. Why molecular formula will be equal to the empirical formula times n, where n is the number of elements present, meaning the molecular weight of the element present there. And so in this case, apart from this expression, there are other ways of determining empirical and molecular formula. For the purpose of this class, we are going to be dealing with the three steps of determining empirical formula. Three steps. One of such steps is determining the molecular weight or the atomic weight of the individual element present. What we mean by that is the compound that actually undergoes combustion. The unknown compound constitutes or are made up of carbon, hydrogen, oxygen, sometimes metals and other, like we previously said in our previous video. Those elements present, if we can find their weight, we have gotten step one. So first of all, we look at determining the weight of each atom present, weight of each atom present in the unknown compound. That's the step number one. Determining the weight, WT means weight, of each atom present in the unknown compound. Number 2 is to determine the percentage weight of each atom present in the unknown compound. So number 1, determine the weight of each atom present. Number 2, determine the percentage of the atom present. And then finally, number 3, ratio of each atom present. Each atom present in the unknown compound. Unknown compound. All empirical formula falls into this. Some of your questions may start from 1, where you have to find the weight of each element present or each atom present, while some questions go as far as finding the percentage weight, meaning they have already given you the weight. You have the weight already of each atom present, but you don't have their percentages. So you have to find percentage. So number 1 is already solved for you, depending on the nature of the questions. Sometimes they have already given you the percentage of each atom present in your unknown compound. All you need to do there, of course, they have solved 1 and 2 for you. You have left it with just what? Just number 3, which is the ratio of each element present. You got to listen attentively, because in the ratio there are rules to abide with. While you get your whole number, because sometimes the number may appear in fractions, and then you needed to round them up or round them down. That will follow the rules of rounding up and rounding down numbers. So you must be careful in dealing with your ratio, especially when your ratio deals with a fraction. When fractions are involved, then you have to mind your rounding up and rounding down of numbers. So these are the basic 3 steps generally used for empirical formula determination, irrespective of the question. Anywhere you see empirical formula determination, apply this. First of all, take the weight of each atom. Look for them. Are they present? Are they giving me the weight? Do I have the weight with me? Is the weight available? If the weight is available, then you go to step number 2, which is the percentage of each atom present. And then number 3, the ratio. If you have been given the percentage of each atom present, do I have the ratio? No. So you find the ratio. So you can actually be given this way. But looking into that 3 steps, we will look at their formulas. How can we get them? There are mathematical formula of arriving at the weight of each atom. So we'll take them one after another. So according to our step number 1, there is a formula for it. So formula used in finding the weight of each atom. Number 1, atomic weight of the atom. Atomic weight of the atom all over the molecular mass, molar mass of the compound, molar mass of the compound, molar mass of the compound times the weight of the compound. I take it again. Atomic weight of the atom or element. Atomic weight of the atom or element. Atomic weight of the atom or element. When we go into the example proper, I will be explaining this properly, one after the other. You must take note, atomic weight of the atom present all over the molar mass of the compound. For example, if I have water, water is a compound. Water has hydrogen and what? And oxygen. Water has hydrogen and oxygen. So if I want to get the empirical weight, if I want to get the weight of each atom here in water, I will say that the weight of hydrogen, for instance, weight of hydrogen all over molar mass of the compound, molar mass of water, that's the compound now, times the weight of water over 1. Weight of hydrogen all over molar mass of water times weight of water. Now, this is expected to be given in the question. Weight of water is expected to be given in the water in the question. So it's expected that the weight of the compound has been given, meaning during the combustion, during the reaction of the unknown organic compound, after the combustion reaction, because this is normally used, the mass spectrometer, which is a destructive means of analysis, is actually used to get the weight of this compound. And so the weight of water produced from the unknown organic compound that undergoes combustion reaction, the weight of water produced is determined in an experimental way. Now, hydrogen, we know already, hydrogen in the compound has 2. So we already have 2. Of course, the weight of the molar mass of water, of course, is 18 times, of course, weight of water. That will be given. When you do this, you have gotten the weight of the atom, which is hydrogen, from water. So when you do this mathematical expression, you have gotten the weight of hydrogen in the water. And so it's very important you get this. So step number 1 is very straightforward. Get your atomic weight of the atom over molar mass of the compound times weight of the compound. Atomic weight of the atom or element all over molar mass of the compound times the weight of the compound. And I have always emphasized that these are always gotten from the experiment. And so when you get this, of course, it will be given to you in the question. and then you do that, you have gotten the weight of the atom. So step number 1, we are done with that. So we'll get down to step number 2. So by our step number 2, determining the weight, the percentage weight of each element present. So that is very obvious. It's easy to get. All you do is the weight you get here, meaning, of course, it's going to be weight of the atom. The weight of the atom, the one you get here, weight of the atom, weight of the atom, the one you get from number 1, divide by the weight of the compound. So weight of the compound of course we are dealing with percentage, so that will give us 100/1. So experiment 2 or step 2, obviously we go with what you have in 1, which is the weight of the element or atom present all over the weight of the compound times 100/1. That will give us our number 2 step. Weight of the atom present. Alright, citing an example, you can say from here now, the weight of hydrogen is going to be weight of hydrogen all about weight of water times 100/1. This will surely give us the percentage of hydrogen in water. This will surely give us the percentage of hydrogen in water. So getting them, you don't need to dance around anything, you just need to focus and then concentrate on these 3 steps. And I bet you, there is no empirical formula question. There is no molecular formula question that you cannot handle. You handle them with ease. And that's why chemistry is a systematic steps. It takes steps. There's no magic, there's no expectation it's supposed to be this. No, it's step by step. So you go that step. So finally, our step number 3, we have to drag us to the ratio. And how do we get the ratio? It's going to be the percentage of the ratio, which is number 3. Number 3, our ratio of each element. We have to give us ratio will be percentage of the atom all over the atomic weight of the atom. Take note, not atomic, not molecular weight, atomic weight times the atom, the weight. For instance, if you take carbon, the weight of carbon there is, atomic weight is 12. So we have carbon. So if you take a sample for carbon, we have that. For hydrogen is 1. So it's going to be weight of the atom all over, percentage of the atom all over weight of the atom. When you do this, that's the ratio. You do this for all, this will be done for each of the atom present in your known compound. A very good point to note, all combustion reaction of organic compounds gives us CO2 and water. Complete combustion of all organic materials. Complete combustion of all organic materials matter the size, no matter the weight, no matter the length, all combustion of organic material will produce us and give us CO2 and water. So certainly CO2 and water are product of the complete combustion reaction of organic compound. And so when an unknown organic compound undergo a combustion reaction, burning reaction, what will happen? CO2 and water is produced. And then what are the composition of CO2 and water? We have what? Carbon, hydrogen, and what? And oxygen. These are the basic composition of both CO2 and water. And so, good enough, we'll be looking at carbon, hydrogen, and oxygen. So, these steps will handle any empirical formula calculation. No matter how complex, how the storyline is being told, what you will get is these 3 steps to arrive at your destination. Your destination solely depends on your ability to take these 3 steps seriously, understood each step, what they mean and what they stand for. I bet you, empirical formula become a thing of the past. It's sealed forever. And so, hence we have known the basic steps by which we can look at empirical formula determination. We look at the examples. Now look at cite some good examples that will enable me to play around with the ratio, especially when it has to do with fractions. So we'll take a question, a good question, and then see how many questions we can be able to treat. Our questions is going to be cutting across all lines. Our question is going to be cutting across all lines, every side. Immediately you arrive at your empirical formula, your molecular formula follows suit immediately. Your molecular formula can be gotten immediately, especially if you have your relative molecular mass of the compound. So, a quick one. We'll look at a very good question. Let's say question number 1.